Hello ladies and gentlemen, welcome again to another video. In this video I'm going to be covering the string in C, strings, texts. So what is a string? A string basically is a sequence of characters stored in a linear data structure. So what I mean by linear, I mean like an array, for example. All elements are indexed with indices. So to put it simply, a string is an array of character. So if you have an array could be an array of integers, array of whatever. So here we have an array of characters. That's a string, okay? So it's just like any other array, except that it is an array of characters. So to declare a string, all we have to declare, we just declare an array of characters. That's it. There's no other like mysterious way about it, just an array of characters. There's something that you have to note here is that the last element of the array has to end with a special character denoted as the \0. The \0 is just a constant that refers to null, which refers to 0. So it's just 0, okay? The number 0. And there's some pretty important concept that I have to note here is that characters are actually numbers. Every character, whether it's the letter A, the letter B, the letter C, the exclamation mark, whatever, every character is just a number that is varying between 0 and 255. So all the characters that we know in our keyboard, the standard American keyboard, are actually numbers. And here's the proof. So I'm going to basically create a character. I'm going to create a character, let's call that C, and then that character will take the letter A. And now I'm going to print a character to the screen. I'm going to print that character C. Now if I try to compile and run, as you can see it prints A. But if I tell the printf function to consider that as a number, I'm going to change that into D. As you can see, it prints 65 because actually that character is considered as 65, okay? And that's actually the reason why we add these here, this format, this %d, because all data, whether it's a character, whether it's a number, they're actually stored as numbers. They're the same. But by those parameters that we add, we tell the printf function to treat them differently. Okay, consider this. It's actually a number, but consider it as a character. So it'll try to parse that as a character. Consider the other one as a number. Consider the other one as a hexadecimal number, and so on. So a character is a number between 0 and 255. So for instance, this capital letter A is 65. Now, a small letter a is another number. It's 97, and so on. So if I try to print all the alphabet, I can do a for loop here. So C, so let's say char C, and then for C starts with the character A, while C is less than or equals to the character Z, C++. And now I'm going to printf the character C, but as a number, not as a character. And as you can see, these are all the letters A, B, C, D, E, F, G, H, A, J, K, L, M, N, O, P, and so on. So if I change that from D to C, it'll try to print that as characters, and as you can see, they are considered as characters. So the point that I'm trying to make here is that every character is actually a number. So why I'm telling you this? I'm telling you this because when we're dealing with the strings, I told you that the last character must be the 0 character. Okay? So if I create a string, we said that a string is an array of characters, and I'm going to fill this string. I'm going to say that str of 0 takes the letter, I don't know, A, str of 1 takes the letter B, and let's say it's a string that has 2 characters. In order for this string to be formatted correctly, I have to say that str of 2, I'm sorry, the last character, str of 2, must take this constant value, must take this \0. The \0 is actually 0. It's the same thing, okay? But they used to write it this way, okay? It's a standard. And as a proof, I'm gonna try to print it. So let's print f a character, or let's print f a number, and I'm gonna try to print the \0 as a number. Now let's see what it prints. And as you can see, it prints 0. So the \0 is a character that is 0, okay? So now if I try to print this string that I've created here, so in order to print a string here, use %s. That stands for string, and then you give the printf function the array of characters, which is str. Now, if I try to print this, as you can see, it prints A, B, okay? Because the third number, the third character is the \0, so the printf function knows where to stop. It'll stop printing character by character by character until it reaches the 0, until it reaches the \0. When it reaches the \0, it knows that the string has ended, okay? It shouldn't read the extra characters after the \0. Let's try to remove it and see what happens. Now, if I try to remove it, well, essentially here nothing happens. But let me show it to you the other way around. I'm gonna add here another character after the \0, the letter J. And as you can see here, when I print, the J was not considered. The J was not printed, okay? So if you remove the \0, either you stop the printf function from printing the rest of the characters, or maybe there are no rest characters. There are no characters after this character, so the printf function will try to print characters that are not characters, that do not exist, that are not part of this program, so that will generate an error. It's going to tell you a page fault. You're trying to access a memory that you do not have the right to access. It doesn't belong to this program. So you're making a big, giant mistake. Just as if you're trying to access, I don't know, here, let's say, for example, you declare this str, an array of 10 characters, and then you try to say str of 100. That element doesn't exist in the array, okay? You're trying to access an element that does not exist, that is not part of this program. So that will generate an error, usually. So when I tested here, it didn't, but it might generate for your machine, or so it depends on the condition. So if you're lucky enough, it's not going to generate an error, but it could generate an error at any time. So basically that's a string. So your string has to add that \0 character for you. So if you say create an array of character and then assign to that array an initial value hello, the C programming language will automatically copy these 5 letters to that array, and then will add a 6th letter, which is going to be the \0. That's going to happen automatically. So let's try to print that, and that's hello. Now what if I, for example, use 10 characters? So hello another time. And as you can see, so that's letter 1, 2, 3. So these are 10 letters. And our array only has 10 elements, okay? So we didn't leave an empty spot for the / character to be stored. So the printf function started executing until it reached something noisy. Maybe it stopped there, whatever. Maybe there's a 0 after that character, so it stopped. But as you can see, it didn't only print hello, hello. It printed something else, which is not part of the string. So in order to fix that function, always declare an extra space here for the empty character, for the backslash character, so that your string gets formatted correctly. And as you can see, adding one extra character space there solved the problem. Alright, whenever you're dealing with characters, I already said that you're actually dealing with arrays, so everything that you can do with arrays you can do with characters. But lucky for you, you can include a string library which contains a bunch of useful functions that are predefined for you and will help you do a lot of stuff. For instance, you can, for example, compare two strings. Okay? You can compare two strings. Now, if you came from other higher level programming languages such as C# or maybe C++, all you have to do to compare two strings is you could use the equal sign, right? It'll compare the entire first string to the entire second string, character by character, automatically, and then return the result for you. Now, this is not the case for C. C is very low level, so when you say like str1 equal str2, str1 is actually a pointer and str2 is actually a pointer. A pointer is a variable that holds the address, so this operation will just compare the two addresses, okay? It'll compare address 1 to address 2, whether they do point to the same location or not. And if these are two different strings, then of course they are not stored at the same location, so this will always return false, unless you are comparing the exact same string to itself, okay? Like you're comparing str to str. So if these are two different variables, then this will always return false. So if you'd like to compare two strings character by character, then this is not the correct way to do it. The correct way to do it is to invoke a function called strcmp, which stands for string comparison. So the string comparison function takes two strings, and as you can see, it tells you here it's a const char pointer, a const char pointer, so you can give it here str. Now let's declare another variable, so to compare with, so str1 of 11 takes, let's make it exactly the same, hello. And now I'm going to compare str with str1, and the result will be a return for this function. So I'm going to declare result, variable called the result here, and then print the result. So result is an integer. And let's see. And as you can see, it says 0. Now, if two strings are equal, then the strcmp function just returns zeros. Zeros means that the difference between these two strings is 0. There's no difference. Okay? So they're identical. They're equal. Now, if you make one string different to the other, and then you compare again, you find, for example, here 1. Okay, let's, for example, add here the letter A, and let's compare again. And as you can see, it shows you 1. Okay, well, 1 means that the str1 is smaller than str0. Okay, so str0, this one, is bigger than str1, because basically this function keeps comparing character by character, and then finally it returns the difference. So 0 minus 0, because they're equal, 0 minus 0 equals 0, and so on, until here it gets to the O minus A equals a number. That number is positive, so it returns 1. So the first string is bigger than the second. And when I say bigger, what I mean lexicographically. So the O is bigger than A, because O, the number that represent the O is bigger. We said previously A is 97 and O is 100 and something, I can't remember, but O is bigger. So the first string is bigger than the second string. Now if we flip this, if we make this, for example, an A here, and then an O here, as you can see, it prints -1. meaning that the second string is bigger. They're not equal, but the second string is bigger. So to put it simply, if you like to compare two strings, whether they're equal or not, just invoke the strcmp function, and if it returns 0, then they're identical. Otherwise, they're not. Okay? So that's the strcompare function. Now, basically, that's the first thing that you can do on strings. That's the first operations that you can do.